This is Alex Pace here with AMP Steelworks, and we're going to be talking about our latest product, the KROM System, and how we use Newton's basic laws of physics to design this thing. So, to get started, I'm just going to go ahead and read through the three main laws that really apply in this situation. Then we're going to go ahead and explain how that converts to a product. Alright, so the first law, an object will remain at rest or in a uniform motion in a straight line unless acted upon by an external force. The second law, force equals mass times acceleration. And the third, my favorite, every action has an equal and opposite reaction. You can use that on your kids, you can use that at the shooting range, you can use that when you golf. Too much beer, you miss the hole. To understand how these laws factor into weapon ergonomic design, let's talk about what kind of forces we have at play. I want you to imagine that this barrel and chamber has a round loaded inside, and there's no furniture or anything like that. We'll say it's floating in some sort of vacuum state and is just hovering in the air for some reason. Alright, so the powder charge goes off, and that energy that's going out in all different directions is trapped from going up or down or out to the side by the thickness of the chamber wall. Okay, so that allows gas to only go back and forward. Now, understanding force equals mass times acceleration, we know that the bullet is actually going to travel a lot faster than the barrel. So this is going to give you your bullet's velocity, and that's going to be where you start talking about ballistics. And the backwards force is what we're talking about, and that's your recoil, okay? So the main forces at play are the weight of the barrel, which is pushing in this direction, and the weight of the bullet, which is pushing in this direction. If you fire this round, both the barrel's going to come straight back, and the bullet's going to go straight forward at a much higher velocity. But there's not going to be any sort of muzzle rise or anything like that. It's just going to go straight. Alright, so now when we talk about a fully built rifle, we have to understand some of the ergonomics at play here. At the barrel and the chamber, you have the same forces, right? Bullets moving forward, that's pushing backwards on the rifle, and the weight of the barrel and the rest of the gun behind it and you are pushing forward and resisting that force. Now let's say your forward hand, which is holding on right here along the stock, it's a support, right? Now, on this particular angle, like we've drawn, that pressure is going to be going in this direction. Your shoulder is going to be pushing in this direction, and your center of gravity is somewhere here, because remember, we're back on Earth, and we have to worry about something like that. So the balance of the gun really matters and plays an effect on how much muzzle rise you get, how much felt recoil you have, amongst a lot of other factors, even the internal designs of the weapon itself. So it's important to remember when you're looking at stock design, as the weapon system moves backwards, your body, if you're a right-handed fighter, the way it's shaped, the recoil force is going to want to come straight back, and that energy is going to follow the path of least resistance, right? And so it's going to move up and slightly to the right, hence muzzle rise and why barrels don't go down, and it just, that force generally overcomes gravity. Now, when we get into talking about Newton's third law and how that applies to this, these fundamentals of how a weapon system works, the equal opposite reaction is if you're supporting and you're putting pressure here in this direction, it's going to have a tendency to go up because you're adding force in a direction, creating a new path of least resistance. So by changing how certain aspects of the firearm are shaped, we can actually guide what happens when that round goes off and where those forces go. And now ideally we want them to come straight back because that allows you to get a faster follow-on shot. Look at the weapon system we designed. This is called the KROM System. I put this on just a basic DT Sport. There's nothing fancy about the rifle itself. The only thing we've added is our muzzle brake, which we've talked about in other videos, which is also designed to reduce recoil and muzzle rise in its own right. But when we talk about the KROM System, what we did was we wanted to change the balance of the weapon system. So we used 3D printing with a carbon fiber nylon component, and we 3D printed a quick bolt-on rail system that attaches to the stock handguard, our foregrip, pistol grip, and finally our adjustable stock. The really nice thing about this system is being hollow and being mostly carbon fiber, it's extremely lightweight. So we've actually changed the balance of the weapon, and we've taken some of the weight off the back end and changed the center of gravity forward just so slightly. Now what this does is it helps the barrel naturally, it gives gravity a little bit more of an advantage when it fires. The natural components of an AR-15 are actually pretty good. Ideally you want a stock that goes as straight in line with the barrel as possible, which with the buffer tube system on M16s, ARs, and most modern battle rifles, that's what you have here. Now what we've done is we've added a cheek guard that's going to help keep the weight of your head from throwing off the balance of the rifle. by giving you a more natural place to rest your head and keeping your head more straight up and down. We've also changed the shape of our butt pad. So this is designed to fit with body armor. It fits right in the section between your shoulder bone and your collarbone. There's enough mass, we extended this out a little bit, so there's actually more surface area for those forces to impact, which reduces felt recoil, but also this allows your shoulder to naturally hold on to the stock and the weapon, so you don't get as much roll to the right or it wanting to move up because of the aggressive texture we used. One of the other critical assets of our handguards is the shape and the direction. When we talked about the shape of that rifle in our example, the force was kind of going in this direction. By angling this down forward and matching the same angle with a pistol grip, we were actually able to eliminate that, and actually the force is coming somewhat downward when you grip the rifle, which is a good thing. And we actually made these the same angle because it actually reduces your draw time. Going from the low ready to the high ready position reduces a pretty substantial margin of movement there, just because of the natural angles of it. It's also smooth. This was at the request of our smith, who's a former sniper. He said it allows you to wiggle your hand around, line up a better trigger squeeze depending on the situation you're in without too much fuss. I also like the texture on the material. It's kind of hard to tell. It's almost got a grainy feeling, but not quite sandpaper. Basically that allows you to get a nice clean grip even if it's wet or muddy or you're covered in sweat, which is most likely. And as you can see, it's pretty strong. We've made all these mounting systems are the same material and holding up a considerable amount of weight. All in all though, this is the basic science that went into the design of this product. We hope you guys enjoy, and leave us a few comments in the link below. And let us know if you're interested. So,
KROM Labs with the 4 wins. Labs from his mountain.